So today I was going to go over what you guys need to be able to name on the test. On the quiz that's coming up next week, you will need to be able to name alkanes, alkenes, and alkynes only for the quiz. For the test, you'll have to be able to name all 6 of these. And then we're going to go over, after these 6, we'll go over the, what are they called? The aromatic compounds and the other functional groups that you'll just need to recognize, but not necessarily name the whole compound. So let's get started. So an alkane is just a compound that contains only single bonds. So it is a compound that contains only single bonds, and when you name them, you just look at the parent chain. So on your notes, you're really just going to have to go back and look at the prefixes for 1, 2, 3, all the way up to 10 carbon chains. So I'm not going to go over those in these videos because it's something you just need to go and look yourself. So an alkane, in order to name them, you're going to look at the parent chain and count how many carbons there are, and then that's the parent chain name. And then we'll talk about when we add a substituent. So for example, this one has a carbon here, 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 and here. So there are 6 carbons. So the prefix for 6 is hex. And then since it has only single bonds, the last part of it will be ane. So hexane. Now, what if we were to add this substituent here? Okay, so this substituent here is called a methyl group. Anytime you have a substituent, the ending for those groups will be YL. So since there's only 1 carbon in this substituent, it would be methyl. So this, in this case, it would be 2, because it's located on that second carbon, 2-methyl hexane. And that's how you would name it. So another example, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in this chain. And let's add a couple of substituents like that. So there is actually a certain way we will need to number the carbons in the parent chain, and that would be to make these substituents have the lower carbon number first. So if we were to number this from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, the first carbon that would have a substituent would be 1, 2, 3, 4. So it'd be 4 methyl here, and that's not the lowest it could possibly be. If we numbered from right to left, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If we number it this way, the lowest substituent number would be 2, and that's the best way to do it. Actually, that's the way to do it. So the parent chain, 9 of them. So the parent chain is going to be NON, okay? That's the prefix for 9. And since it is all single bonds, it's going to end in ANE. So nonane, okay? And then we have different substituents here. These 2 substituents are the same, and they are methyls. So they will be, if there's 2 methyls, they would start with di, since there are 2 of them, methyl. And they are located on the 2nd and 6th carbon, so it'd be 2, 6 dimethyl. Now we have, on the 4th carbon, we have an ethyl, okay? 1, 2 carbons there. So it would be called 4-ethyl. So when you name it, you would just write, this is its own thing. So when you write it, you're writing 4. Oh, and you need to do it in alphabetical order. So since we're not looking at the M and the E, now that it's dimethyl, the D will actually come first, A, B, C, D, E. So I was about to do it wrong. Now, the new name would be 2, 6 dimethyl 4-ethyl. I did not give myself enough room. So the name of this would be 2, 6 dimethyl 4-ethyl nonane. Right, so that's a small amount for the alkanes. Alkene is the same rules, except if it ends in E, that means there's a double bond, and we will need to indicate that double bond. So for example, if I just said hexene, so if I just say hexene, then what's assumed is, for 1, hex is the prefix for 6, so 1, 2, 3, 4, 5, 6. So that would be the parent chain. So the only thing I can assume if it's hexene is that the double bond will be on either side, one or the other. However, if the double bond is here, I actually have to indicate which carbon this double bond starts on. So now I have to number it where the double bond will start the earliest. So 1, 2, 3, 4, 5, 6. So it starts on the second carbon. So when you name that hexene, it would be just 2-hexene. Now, not always are they just going to have one double bond. So if they have, for example, here and here. So again, this is 1, 2, 3, 4, 5, 6 carbon chain. So that's hex for the prefix. You have 2 double bonds. So it would be hexadiene. Okay, that di, the A is just to make it sound better. Di is 2. If there were 3, it'd be tri, hexatriene. So this would be called 1, comma, because it starts on the first one, and the next double bond starts on the third carbon. So this would be 1, 3 hexadiene. Now what if we had 3 and the double bonds are here and there are 3 of them? So again, the prefix is hex because there are 2, 3, 4, 5, 6 carbons. So this, in this case, since there are 3 double bonds, it'd be hexa tri for 3, okay, triene. And we need to indicate each of them. In this example, not this or this, but in this example, you could have started on the right to left in the numbering just because it really didn't make a difference. So this would be called 1, 3, 5 hexatriene. Now, what if there's a substituent on here? So what if there's a substituent on here? Let's say right here. I'm gonna go all the way down so it doesn't look like 1. And then there is a double bond here. So let's look at this. So if we number it left to right, we have 1, 2, 3, 4, 5 is where the double bond would start. 6, 7, 8. If we number it right to left, 1, 2, 3. So there is a list of priorities as far as where you number your parent chain carbons. And the list goes like this. The most important, let's do a bigger one. The highest priority will be an alcohol. So if there's an alcohol in the molecule, you definitely want to put this one on the lowest number of carbon. If there is an amine present, this is second in priority. Then we have double bonds. Then we have triple bonds. And then, of course, alkynes or single bonds, or we've been calling them in class substituents. Okay, so this is the order of priority, most important to least important. Okay, so this is a list of the priority when we're naming and numbering that parent chain. So when we number this, even though this would be on the second carbon and you would think that it would make sense to make this 1, 2, but since not the alcohol, that's not an alcohol, since the double bond has higher priority than a substituent, we need to start from right to left in numbering. So 1, 2, 3, 4, 5, 6, 7, 8. So its prefix is oct, okay? Then we need to indicate where that double bond is and how many double bonds. So there's only 1 double bond on here, so we can go ahead and call it octene. But we just need to indicate where that double bond starts, which is right here on this third carbon. So we'll say 3-octene. And we do need to address this methyl group right here. So the methyl group is located on the 7, and it's called methyl. There's only 1, so that's it. So it's 7-methyl-3-octene is the name of this. Simple. Alkynes, basically same rules, same naming, everything. It is lower on the priority list than a double bond, so the triple bond is lower than the double bond, but definitely higher than a substituent. Which way do we number? It does matter here because we do have a triple bond, and the triple bond is more important in priority, or we do start the numbering closer to this one where it has the lower carbon number than this one. So we need to number it from left to right. So 1, 2, 3, 4, 5, 6, 7. So its prefix is hept, for sure. And then we have this double bond, triple bond here. So when you have a triple bond in the structure, it ends in Y-N-E. So it's heptyne. And we do need to indicate it. If it was on the first carbon or the last carbon, well, actually we would have, it would be on the first, just flipped, but whatever. If it was on the first one, we can leave it here, but it's not. It starts on that second carbon, so we're going to indicate where that triple bond is. Now we need to talk about these substituents. Technically, you could have put 7 up here. That would be just as fine because remember this molecule can flip around and these aren't flat on the paper like I've said in class. But this is 1, 2, 3 methyls. So there are 3 methyls, so we're going to call it trimethyl. That tri just means 3. Trimethyl, and we need to indicate where. So we have 4, 5, and 6 trimethyl, and then we just add them together. So 4, 5, 6 trimethyl 2-heptyne. So that's how you would name that molecule. Moving on to cycloalkanes, these are just as easy as these. The only thing that's different than what we've done is that you will add cyclo in front of it. So let's say we have this molecule right there. This molecule is called butane. So you have 1, 2, 3, 4 carbons. So that's just butane. Now, if this was a cyclic compound where we have it closing in on itself, so there's still 1, 2, 3, 4 carbons, just add cyclo in front of it. So this would be called cyclobutane. Let's say we have this one. This is cyclopropane. Okay. Really, in 10th grade, all we're going to deal with are the ones I'm writing. This would be cyclopentane, since it's 1, 2, 3, 4, 5 carbons. Then we have 1, 2, 3, 4, 5, 6 carbons, so that's hexane, but we would add cyclo in front of it. Cyclohexane. That's probably all you're going to get in my class and my test. And like I said in class, it really doesn't matter how you number it. When I do my keys, I usually number 1, 2, 3, 4, 5, 6. And when it's standalone like this, it really doesn't matter when you start numbering it because this thing can like rotate in real life. Rotate clockwise, counterclockwise. It can rotate forwards and backwards. So it's not stagnant. So really, honestly, it doesn't matter where you number it. But when it does start to matter is if there is this longer parent chain and then they become actually a functional group and not necessarily the parent chain, and then the rules change. But in my class, we are not going there. We are just doing the basics, and that's just adding your cyclo in front of the parent chain name. Alcohols. When you are naming alcohols, you will be, let's change. When we name alcohols, there are a couple of things you do need to know for the test. So there are primary, secondary, and tertiary alcohols. So when you're naming alcohols, first just look at the parent chain name. So let's say we have, now there is 1, 2, 3, 4, 5, 6 carbons. So the parent chain name is hexane. Okay, that's just the parent chain name if we forget that. With the alcohol, you have, if you look at the list of priorities, okay, you'll notice alcohol is number 1. So if there's an alcohol present on the molecule, you definitely number it first, where that's the lowest. So we will name it 1, 2, 3, 4, 5, 6. So this would be hexane, but with the alcohol present, we do need to change the ending. So take the E off and add OL. So it's hexanol. Now, let's say we have this. So let's say we have this molecule. We need to talk about where we start numbering our carbons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in our parent chain. So you know the prefix will be NON. Now the ending will change. It is an ane, so it would be nonane, but we're actually going to name the alcohol. Since there is an alcohol on it, it will have OL at the end. I know this sounds like something very silly and it doesn't sound right, but that's just you don't see that often. You hear like ethanol, methanol, but theoretically, if you had 9, it would be nonanol. And then you have to number your carbons. It seems like you would want to number it from left to right, but again, alcohol has the highest priority. If you look at the list, alcohol has highest and substituents actually have lowest. So we have the alcohol, so we have to number it from right to left. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have to number it right to left because if we were to number it from left to right, 1, 2, 3, 4, 5, 6, the alcohol would have would be considered on the 6th carbon, and that's higher than 4. So that's why we had to number right to left. So now we just need to indicate these methyl groups. So these are all 3 methyl groups, so it'll be trimethyl. Let's just indicate our alcohol real quick, 4. Trimethyl, and then we just need to write the numbers. So 6, 7, 8. 6, 7, 8 trimethyl 4-nonanol, if this was a thing. So primary, secondary, tertiary alcohols. So remember alcohols, you're looking at the carbon. You're looking at carbon. The alcohol, oh, I can't spell. It's not alcohol anyways. I'm trying to say hydroxyl group. Look at the carbon, the hydroxyl is on. So what that means is you're looking at if carbon is attached to the hydroxyl group, we're looking at this carbon to determine whether it's primary, secondary, or tertiary. If it's primary, it's either methanol or has only one, that's supposed to be a carbon, only one carbon connected to it, okay? And then the other 2 hydrogens. So on this one, if the carbon that the hydroxyl group is connected to has 1 carbon on it or none, it's primary. If the carbon has 2 carbons on it that the hydroxyl group is connected to. So the hydroxyl group's connected to this carbon, so we're looking at it. And there are 2 carbons connected to that one, it's secondary. If the carbon that the hydroxyl group is connected to has 3 other carbons connected to it, that's tertiary. So with alcohols, you're looking at the carbons to determine if it's primary, secondary, or tertiary. Now, why I'm stressing that is with amines, you're looking at nitrogen. So remember amine, if you remember in biology, amino acids, that just means that it contains nitrogen. So we're looking at naming amines, and there are only 3 amines I'm going to possibly ask you about on the test. I'm not going to have you name all possibilities. So if you'll remember what we've learned at the beginning of the year, nitrogen has 5 valence electrons for each of them. So that means nitrogen can only bond with 3 things because it needs 3 more to have its octet. So if nitrogen has 1 carbon bonded to it, the other 2 would be hydrogen. Then that is, we're looking at the nitrogen now. That's in contrast to looking at the carbon, okay, connected to the hydroxide. But here we're looking at the nitrogen. And if on the nitrogen there's 1 carbon, that's considered primary. If there are 2 carbons connected to the nitrogen, 2 carbons, then that is secondary. If all 3 bonds are carbon, that's considered tertiary. So the main difference between alcohols and amines in determining primary, secondary, tertiary is that with the amines, you're looking at the nitrogen to determine primary, secondary, tertiary. And in alcohols, you're looking at the carbon, the hydroxide, or the hydroxyl group is on to determine primary, secondary, tertiary. With either of these, what you're looking for is if there's 1, 2, or 3 carbons attached to it. Now, with this one, it could be 1 or 0. Here, it's going to be 1, 2, or 3. So those are the 6 types of organic molecules you will be naming on the test. On the quiz, you will name alkenes, alkynes, alkenes. And then on the test, you'll name all of them. So on top of the things you will have to learn how to name, you will have to learn how to recognize certain functional groups sticking off of a molecule that you won't be required to name. So, for example, we already know most of those functional groups from what we just talked about, right? So we already know what an alkane is, right? We already know what an alkane is. We already know what an alkene is. We know what an alkyne is. So just single bond, double bond, triple bond. We know those already. First three things we've talked about. Amines, we talked about those as well. And that has nitrogen in it, similar to that. Then we have alcohols, and that's when you have a hydroxyl group connected to a carbon of some sort. And we'll say the amine is connected to a carbon of some sort. And what the R means, I've said in class, but what the R means is basically like the rest of the molecule. And I'll show you some examples in a minute. But we know these already. We know these 1, 2, 3, 4, 5. We know the first 5. 1, 2, 3, 4, 5. Okay? These we've already discussed and shouldn't be that difficult to recognize. Now, there is a slide in your notes with more complex functional groups that you need to recognize. There's one super easy one called an ether. The ether, let's write his name. The ether is, to me, the most easiest to recognize functional group in a molecule because it's just kind of different than the others that I have you recognize. So let's say you have this long carbon chain and then this random oxygen in the middle. That's called an ether. That oxygen just sticking out in the middle of the molecule. So that one should be another easy one to memorize. The last 1, 2, 3, 4, 5 are pretty difficult just simply because of how similar they are. They all have this double bond to an oxygen bonded to a carbon here. And then whatever is bonded to that carbon will kind of determine what functional group it is. So if it is, let's move on over here. Let's say that oxygen, okay, is double bonded to that carbon, and that carbon is just bonded to a bunch of other carbons in the molecule. I know it looks like a spider, but if, actually it looks like a bacteriophage, but if it's bonded to the rest of the molecule, that's just considered a ketone, okay? So if you have a molecule and then all of a sudden there's this oxygen with no other oxygens or nitrogens around, it's not the end of the molecule, it's just right there in the middle, you can just consider that a ketone. So I think the ether and ketone are super easy to recognize because again, they're in the middle of a molecule and they're not like terminal, which means at the end of a molecule, and there's nothing else really to look at. Some of them have H's, some of them have another oxygen, some of them have nitrogens, and that's kind of where you need to focus in on your like studying. So you have the ketone, and to me, again, that's easy. Now, another easy one to recognize is the amide. The amide is easy to recognize because it has if you can tell by the name, it has a nitrogen in it. So if you have this long molecule, and it could be however long, it could be hundreds, it could be just 2 carbons, whatever. And then there's this oxygen again, okay, with the double bond that indicates, hey, I gotta look at this is a functional group. So if you see this, but then there's this nitrogen attached down here, that's going to be your amide. All right, so the slide has amide as NH2. Something that could keep going is that these could be R groups. So that is one other thing that I think may be misleading from the slide, is that it also could be ending there, or they could even just keep going, okay? So when you have this oxygen with the end down here, these are both amides. So that's another easy one because amide should, in your brain, make you think of a nitrogen. So to me, the most difficult ones to like get straight are the aldehyde, the ester, and the carboxylic acid. These 3 are kind of similar, but also in a way not. And so aldehyde, let's start there. So an aldehyde ends, it's terminal, or what that means is like it's at the end of a molecule. So what that means is it would go the double bond and the oxygen would go here, and this is a carbon. So this carbon needs 4 bonds. So there's 1, 2, 3. And then this fourth one is not an R group, that means more carbons can go. This last one is just a hydrogen. So the aldehyde has to go at the end of a molecule because the other thing connected to that carbon is a hydrogen. So that's one thing. So look for that hydrogen. I guess I would circle it. This right here is the distinguishing factor from an aldehyde. Because if you look at the carboxylic acid, it has, where's my blue? Here it is. The carboxylic acid has the double bond here. But then here, connected on this carbon, is an oxygen. So this oxygen has to have an H here. So the difference between aldehyde and carboxylic acid, they're both terminal, but that difference is this. You have an OH. Okay? It's terminal though, so these two are both, okay? So they're both at the end of a molecule. Now, an ester can be in the middle of a molecule. Let's do it with purple. So the ester could be, let's draw the ester. So the oxygen with its double bond is here, and bonded to the carbon has to be an oxygen. But after the oxygen, it's not an H like the carboxylic acid. It is an R group, which means basically carbon. It can keep going. It's not terminal. So if you see a double bonded oxygen in the middle of a molecule, and it's not alone, like this ketone, it has that oxygen down here, it's an ester. If it's at the end, it's going to be carboxylic acid or aldehyde. The difference between carboxylic and aldehyde is the presence of this guy. Another functional group I'm going to ask you to recognize, something like this. There will be aromatic compounds, and that would also be a functional group. I'm not going to expect you to name a molecule with this in it, but I will expect you to recognize this within a molecule. So what will that look like? Let's just draw an example. So let's just look at what, on the test, you'll have something like this, something crazy. And I'm going to ask you to name the functional groups that you see. So what you'll do is you're going to look at the whole molecule and start to identify what are functional groups and what are not. So for example, you can tell that, okay, I'm going to have to look at something here. There's something here. There's something here, here, and here. So I'm not just going to ask you to circle them. I'm going to ask you to tell me what functional groups you see. This one's easy, right? This is an aromatic compound. Next, something that you need to recognize is here. So this is terminal, but it has the oxygen and not the hydrogen. So when it's terminal and has an oxygen, this is a carboxylic acid. If it's terminal with no oxygen, just a hydrogen, okay, just the hydrogen, that indicates that it's the aldehyde. This one should be easy to recognize because it's different than the rest. This one is an ether. Okay, when you see just the circle, just the oxygen alone. Now, if you have a double bonded oxygen in the middle of a molecule with the oxygen here, but more molecule afterwards, that's going to be that ester. It's not terminal. Ester. So that's going to be similar to your test as far as recognizing these on your quiz. Again, you're just naming the alkanes, alkynes, alkenes. And then get used to recognizing these within a molecule. Now, what if, just for fun, what if that was in? If that was in, it would then be considered the amide. Amide, though, could also be terminal if it wanted to be. Not wanted to be, but if it could also be terminal. It can be in the middle of the molecule or terminal. If it was terminal, it would be something like this. The N would be here, and it would just have H's and then the double bonds. So that would also be an amide. So I hope that helps. This is naming quickly. I'm not going through the whole PowerPoint. We went through it 4 or 5 days in class. So this is kind of like a review, overview, whatever.